Hi, myself Karanveer Singh, and our work is titled as Towards Digital Twin of Crops for Growth Modeling using Virtual Reality. But first, let's talk about what is digital twin. A digital twin of an entity has three things: the entity itself, its digital entity, and the interaction between them. Therefore, there is a need to have the digital representation of the entity. Now, for crops, we can have two of those, internal and external. In the internal representation, we can include things like moisture, temperature, starch content, and electrical conductivity of the crop. Whereas for external, we can have appearance or 3D mesh. And our work focuses on external aspect. So in our work, we created a virtual reality framework which stores the ideal growth trajectory of a crop. Now in our case, we selected cauliflower crop and grew it under lab settings environment. Then we took photographs using smartphone and this apparatus, and we finally fed the photographs into Mushroom's 3D reconstruction pipeline known as Alice Vision. Once the pipeline runs, we get a 3D model of cauliflower crop on that particular day. Now this process was repeated for 13 days and we eventually got 13 models. All of those models were aligned using the ICP algorithm. Then a Unity VR framework was made through which we can switch these assets from day n to the next day. So now let's talk about the analysis portion. Here we propose an average alignment error metric which involves finding the representative point of each 3D asset. Now we consider the center of this upper circular ring as the representative point for that asset. Now overall we will have 13 of these points. Using these points, we find the alignment error between each consecutive pair of transition, which is given by this formula, where this is just the Euclidean distance between the representative points. Then we take the average to get the final AAE value. And here are our calculations. And the final AAE value for our case was 0.0656. Now, lower is this value, the better is the alignment. So after that, we also performed qualitative analysis, which involved a user study of 17 participants where they were asked to give ratings to each transition on the basis of change in position, orientation and size of the pot. Now their ratings were converted into normalized inverse average rating using this formula. Now we have two quantities from the quantitative analysis and the qualitative analysis, and their Pearson correlation coefficient was found as 0.7564. which shows that there is a strong correlation between the two quantities, and here are the future improvements that can be done.